data management pattern. How the data is managed within the microservices. Okay, so there are multiple patterns available. Okay, so let me go one by one. Okay, so the first pattern is called every service has its own database, right? So in the database per service pattern, let me stick to the e-commerce platform. There itself we will talk about this all the patterns. Okay, so the first thing is called as a database per service. So for every service I will have an individual pattern. That's what I have shown in the diagram. Okay, so here you have the responsibility of collecting the data and storing the data for the centralized operation thing. Okay, you need to have the OLAP database, right? Where all the information from the respective database has to be collected and stored. Okay, so that is one additional activity you have to do when you are going to do a database per service pattern. Okay, so if you implement that, so you will be having you have additional work of syncing the data from individual database to a centralized OLAP database. Okay, and next concept is called a shared database. That means a common database will be used by multiple services. Okay, but there will be a problem or limitation in the shared database concept, where the teams which are using the database must collaborate well, so that if this team, let's say I am having a team A which is managing service A and team B which is managing service B, if both the teams has to be collaborate in better way, if team A is making some changes to the database, that changes has to be done on the done by the team B also. Otherwise, you will have a problem in the management. So this is not a better way of microservice, but some of the cases you cannot avoid it. In that case, you can use the shared database, but you should be very careful while making the changes in the database level. So if you are making some databases, all the other services which are using the database should be notified about the change, and they should make the changes if they are making some if they have to make the changes in their application, in their particular service. Okay, so which is something similar to the monolithic, but try to avoid the shared database. But on some cases we have to stick with this shared database. Saga is something like, imagine when an order is came in, the order service received it. Okay, it creates two sagas. Okay, so basically it creates a message and send it to a message queue. So the customer service is going to consume the message broker and see. So this is a scenario in a prepaid model. Okay, this diagram is an example of a prepaid model where I have some credit on my account. When I place the order, it is going to check whether the customer is having enough credit to buy it. Okay, so the customer service will get the message from the MQ, okay, and validate with my customer credit balance. Okay, and if I have the enough balance, it is going to reply to another MQ channel, that is reply channel, and this create order saga will be looking on this message broker. Okay, and from there it will get that and it will update the order. So this is one way of Saga based communication in orchestrating between two different databases or two different services. API composition. So this is also pretty straightforward. Like if the in the same example where I'm showing, instead of using a Saga, what it will do, order service will call the customer service and ask for what is the credit available for the customer. Okay, and based on the credit information, the business logic will be returned on the order. So here the ordering service is doing the work of a customer service, or otherwise it can pass the information saying that this customer is trying to order this much like 1,000 rupees worth of product, does he have the enough credit? So the customer service is going to respond saying that he has the enough credit. So those kind of communication can be happen. That is a typical API composer, but here the number of calls will be higher compared to the Saga method. Command query responsibility segregation. Okay, so this will be a typical example of this. So this is where the automated update on the OLAP comes into picture, right? So if you see the previous example, I'm not updating any of the OLAP thing. I'm just using MQ to communicate between these two services. But this is where the automated update of the centralized database is going to come into picture. Okay, so this is an example of a Swiggy kind of application. Okay, so your order is placed, that is going to create an event, okay, which will be directed to the where it is going to update the order history database for me. Okay, so even though the order service has its own database, it is going to create an event, and that event will be pushed on to the order history service, and from there it will be written to the database. So this is what the example which we have seen in our e-commerce site. So it was using command query responsible segregation. So this concept is called command query responsibility segregation. Next method is called as a domain event. So basically here for every domain they have a separate database. Okay, it is something similar to the CQRS, but it will be domain specific, right? We talked about the domain driven design, right? Where I will have a separate domain for core functionality. I will have a separate domain for my general tools, and I will have the separate domain for the supporting function. So for that, I will use the particular database. So it is combination of CQRS, implementation of CQRS on the domain level. Event sourcing. So there will be an order service. When an order is placed, it will be stored in an event store. Okay, and the order service will be writing it. Okay, and consumer service, the customer service will be subscribing to the events, and it will be matching the status. It will be keep on updating it. Okay, so people will use combination of services in the data layer. So the best data sources I would say about is called the CQRS with the database per service. So this avoids lots of confusion, or otherwise you can also use the shared database, but there you are taking a risk of sharing the database with the other application. Okay, so database per service, Saga and CQRS might be a good implementation on a microservice, data management for a microservice. Transactional outbox. So like for example, in the CQRS, when I'm going to write, I don't want to write any separate service for that. Okay, then I can use this kind of scenario where when I'm writing on the table, okay, I will write it on writing on a database, I will write it on two table. Okay, let's say when order service, it will actually update a order table, and there will be an outbox table. Okay, and I will have a message relay configured. Okay, which will be reading from the outbox table and posting it onto the. This is something which we in the Saga method, this method will be used. Okay, instead of writing it on the one table, I'll be writing the data on two tables. Okay, so the Saga method will monitor the outbox table, and that message will be put onto the message broker. So to automate that. Okay, this is called as a transactional outbox. And next thing is called the transaction log tailing. Okay, so every database will have a transaction log. So this log we will be using to sync up to database. So the same log can be read to generate the message for the message broker in the Saga. This is another method. So whenever you are having an active and passive databases, there will be a transaction log. So the transaction log will be shipped to another database. From there, the data will be synced. Okay. So that method can be used to generate the message broker events. Okay. Another method is instead of writing on multiple tables, I will be having a service which will be keep on reading the order table. When a new entry comes in, I will automatically write it to a message broker. So these are all the multiple methods which are used to generate transaction messages for the Saga method. Okay, either I can configure the application to write it in 2 tables, or otherwise by reading the transaction log, I can identify that, or otherwise I can run a query on the table, keep on polling the table. Any new record comes in, I'll be writing it to the message queue. So this is called the transactional messaging.